Everybody, welcome to SDN Bit. In this channel, we're discussing network automation and programmability concepts. And in today's video, we are going to talk about MDP. As you can see here, it stands for Model-Driven Programmability. So let's get started. The first question we should ask about MDP is, why do we actually need model-driven programmability? How this concept came into realization? And the answer to this question is as follows. Traditionally, network engineers used two tools and methods to manage network infrastructure. The first tool was SNMP, a protocol which allows us to monitor entire infrastructure. So let me just indicate its name here, SNMP. We were using SNMP for network monitoring, basically. And network monitoring means working with operational data of network devices. So network devices can have two types of data. The operational data, which we fetch from devices to analyze statistics for analytics purposes. And then we have configurational data, which we modify in order to change the device's behavior. And in order to work with configurational data, we use the second tool, which was the CLI. So for a very long time, just these two tools were doing a good job, right? SNMP was great when it comes to network monitoring. You could use tools like PRTG, Zabbix, Cacti to monitor your entire infrastructure. And you could use CLI with SSH by connecting to devices remotely and configuring them on the CLI line, terminal line, and change network devices' behavior. In the early 2000s, the big companies, providers, large enterprises came into realization that these two tools are not sufficient to handle scalable networks. So networks were growing, amount of devices were increasing rapidly, and it was extremely inefficient to handle entire infrastructure using just these two methods. Besides, they also tried to use SNMP to configure network devices. So if you actually make a research, you will find out that SNMP was developed not just for network monitoring purposes, but also for network configuration management purposes. You could use SNMP's MIBs and hierarchical architecture to configure devices, but because of SNMP's complex hierarchical structure and inconsistent MIBs, it was almost impossible to consistently manage network infrastructure, to consistently manage configurations. So basically, SNMP failed in this domain. It was good for network monitoring. It is still good for network monitoring. However, it failed for network configuration. CLI was good for network configuration, obviously. It's also used today. It's also widely used today. We did not completely forget about CLI. We did not abandon this method. But the drawback of CLI, the primary drawback at least, is that we cannot configure multiple devices at the same time. That's basically the primary drawback, but we have a lot of negative aspects, which we'll talk about later. So in early 2000s, all these companies, all these enterprises, vendors, organizations of standardizations, they came up and they decided to have a meeting and discuss what they could do to tackle this issue. What they could do. They couldn't obviously use SNMP again. SNMP failed. Its SMI data model, which is data model for SNMP, it's called SMI. It was also incompatible with network devices. So they had to come up with new methods. And they come up with something called netconf. And netconf is a protocol which is designated for network configuration, as its name implies, netconf, network configuration. But netconf was just a transport method for a configuration of a device. So you still need something that basically allows devices to understand what needs to be configured. And the other problem at that time was also the difference of networking vendors. So every single networking vendor, whether it's Cisco, Juniper, Huawei, whatever, they had their own syntax, They had their own regulations in their own, devices, and it was extremely difficult to find a common tongue to be able to speak to all these devices. And most of large enterprises and providers, they had multi-vendor infrastructure consisting of different devices from different vendors. So they also added this problem to the list of the problems which they have to fix. And later they came up with something which will be used with netconf to address this issue, and that thing is Yang. Yang is a data model which allows netconf to explain networking devices on how they should change their behavior, let's say. This is very high level view, obviously, but it's just very simple to explain it in that way. So that's why I'm using these analogies. So basically, netconf is a protocol which was designated for network configuration purposes. Just for network configuration, nothing else, not even monitoring, nothing else. It can be used as a monitoring, but that was the primary purpose of it. But again, network was a primarily transport method, transport protocol, let's say, to be able to establish sessions with devices so you can speak with them. And netconf needed something else to actually speak with those devices, to let engineers to execute commands and work with operational and configurational data, right? So they came up with this concept, and netconf plus Yang created a completely new concept in networking world, which is called model-driven programmability. And it is called model-driven because Yang, I will write its name here, Yang is a data modeling language. So the entire idea of model-driven programmability is you specify a standard, consistent, common model which is understood by most of networking vendors and their devices. And by using this model, this one unified model, you can configure devices, you can work with operational data, and you can basically manage your entire infrastructure. So the core of MDP, the core of model-driven programmability is Yang data model, as it is illustrated here. Cool. So what happens when we actually deploy these methods to use? Like why this is better than SNMP and CLI? And it turns out that it has multiple, let's say, benefits. And I have listed these benefits here in the right side of this screen. And before going into this, I will also break down the architecture of model-driven programmability, as you can see on the left side. So let's first talk about the architecture, right? As you can see, we have multiple layers here. We have models, transport, encoding protocol, APIs, and apps. So this architecture might seem complex, but just this architecture allows us to fix problems which we encountered with CLI and SNMP, right? As you can see, in the top of this, we have applications. So applications could be different applications, or it can be basically a network engineer running commands. So just imagine this layer as yourself, as a network engineer who wants to get operational data from devices or to push configurational data to change devices' behavior, right? Then we have APIs. APIs allow us to interact with devices, and model-driven programmability has model-driven APIs. We also have Yang Development Kit, which is a software development kit intended to simplify work with Yang models. Then we have a protocol layer. And in protocol layer, we have 3 different protocols indicated: netconf, restconf, gRPC. We are going to talk about these protocols separately in next videos because they have their own way of working, their own mechanisms, and we'll discover that later. But for now, we'll just say that these protocols are primarily intended for transport of commands or requests which we issued to the device and back. Okay, so these protocols make sure there is a request response happening in transport level, let's say, right? So netconf, restconf, and gRPC, and all these protocols, they cannot use CLI because CLI is something that we used for our own comfort. Basically, we're using CLI as network engineers to be able to understand the input and output of text which we type and send to network device. The primary goal and, let's say, benefit of CLI was that it was comfortable for humans to read the text, right? So CLI is easier for us humans to read and understand information. But when it comes to devices are not really, fond of parsing CLI content every single time. They would be much more efficiently used if we actually use data formats or data encoding. So basically, machines prefer to speak these languages, not languages, but formats, to understand each other better. And these formats are XML, JSON, and, for example, GPB. We can also have YAML, which hasn't been identified here. And then we have transport. This is transport of layer 7 in the OSI model. So in the layer 7 of OSI model, we can use SSH or HTTP in model-driven programmability. So why they use these two protocols? And the basic idea here is that most of networking infrastructures already using SSH for CLI. So they said that there is an already existing SSH configuration on network devices. So if we were using CLI previously, let's just keep SSH as layer 7 protocol. It is secure. It can encrypt entire data, which goes and comes from the device. And we can use that as a layer 7 transport method to be able to configure devices programmatically, right? Not with CLI. And then you have HTTP. HTTP is also very, very famous protocol. It's almost used everywhere. It's very easy to use. We use it pretty much every day when we basically surf on the internet, type some URL in our browsers. So they said, let's keep these existing protocols and let's use all their features and capabilities alongside with model-driven programmability concepts. So that's a big plus. That's a huge plus because most of the devices in networking world today are already ready for SSH and HTTP use because they have been already configured before. And the last layer here is models layer, and we have just one model, the Yang model, which was specifically designated to work with network configurational and operational data. And Yang models can have two types, the native and open. We will also have a separate video about Yang models in the upcoming videos. For now, just think about it like a common, standard, and unique model which allows every single vendor, almost every single vendor and every single networking device to understand each other, to understand basic network services and device configurations on a similar level. So that's pretty much it. And let's now talk about why MDP is efficient, why MDP is better than CLI, SNMP, and other traditional methods which we used before. So the first benefit is abstraction and simplification. Model-driven programmability allows network engineers to work at a higher level of abstraction instead of dealing with low-level configuration commands. They can focus on defining and manipulating models that represent network resources and services. This abstraction simplifies the complexity of network operations and enables more efficient and scalable automation. That was the first one. The second one, consistency and standardization. By using standardized data models, such as Yang, which is common for everyone, model-driven programmability promotes consistency and interoperability across different network devices and management systems. With SNMP, we didn't have consistent standardized data models, or with CLI. Every syntax was different. Every SNMP architecture was different. The interoperability of different vendors and devices were almost impossible to achieve, and it was very time-consuming to configure this. So consistency and standardization, which MDP provides, facilitates a lot of issues, right? It provides a common language for describing network elements, attributes, and relationships, ensuring consistent configurations and reducing configuration errors. Basically, what does it mean? You can use Yang data model to describe every single, possibly most of, network device features, attributes, or relationships with just one model. You can use one model to describe everything, and if every single networking vendor uses this model to describe their particular attributes, relationships, you can have one model which allows you to understand everyone. It's like everyone agrees to speak in one language. So you don't have to know multiple languages, right? It's just more efficient. The automation and orchestration. Model-driven programmability enables the automation of network operations and workflows. With well-defined data models, such as Yang, automation tools can easily generate and deploy configurations, monitor network state, and trigger actions based on specific events. This leads to faster provisioning, improved network efficiency, and reduced manual effort. Again, because you have a single model which describes everything in a very well-fashioned, very well-defined, you can push your configuration changes, you can monitor whatever you want. Because it's stable, it's consistent, it's understandable by everyone, it will be extremely easy for you to do whatever you want with your infrastructure. After, vendor neutrality and multi-vendor support. Model-driven programmability allows network engineers to abstract the underlying infrastructure details and focus on the intent and requirements of the network. This vendor-neutral approach promotes multi-vendor interoperability and flexibility, enabling the integration of devices from different vendors into a unified network management system. Basically, you can have one network management system, and you don't have to learn the syntax of your network devices from different vendors. So let's say in your infrastructure, you have a Cisco device, bunch of Juniper devices, bunch of HP or Huawei devices. Instead of learning a syntax of Cisco, Juniper, or Huawei and memorizing it and trying to deploy configurations with those different syntax, instead of doing all these time-consuming tasks, you can learn to work with Yang model. You can specify and describe the configurations in this model, and then using one common language, one method, you can basically handle and manage your networking infrastructure as you want. Enhanced network visibility and analytics. With model-driven programmability, network devices expose their operational state and telemetry data in a structured manner. This enhanced visibility allows for better monitoring, troubleshooting, and analytics. Network operators can collect and analyze real-time data to gain insights into network performance, identify bottlenecks, and make informed decisions for optimizing the network. So basically what we're talking about operational data and configurational data, right? So I will just indicate here. So we have operational data. I'm going to say oper shortly. And then we have configurational data. So again, configurational data is used to change devices' behavior, how it acts in the network. And operational data is necessary to make sure device is working properly, to monitor device, right? Show commands, debug commands, to get information from the network and to analyze it. You can do it in SNMP, with SNMP obviously, but with netconf and with other MDP methods, you can do it even faster and more efficiently because its configuration is easy to begin with. So every single device already has predefined Yang models installed in it. All you have to do is just specify which Yang model you want to get information from, right? So the configuration steps to monitor your device for analytics is so much easier with for example, netconf or gRPC, because all you have to do is just specify one Yang model, right? But when it comes to SNMP, you have to specify object IDs. You have to search for these object IDs. You have to make sure MIBs are consistent. You have to integrate other tools. So there's a lot of work that needs to be done to set up network monitoring environment with SNMP. But with netconf, it's so much easier, and at the same time, it allows you for more features. You can monitor things which you couldn't monitor before with SNMP because it was unavailable or unsupported. But netconf provides more features, and it's just way more faster. And with telemetry, with streaming telemetry, you can actually you can actually get data not with intervals of minutes like you use in SNMP, but you can get real-time data, which is even more efficient. And lastly, easier DevOps collaboration. Model-driven programmability facilitates collaboration between network engineers and software developers. Both teams can work with the same data models, enabling seamless integration of network automation with broader DevOps processes. It promotes the use of modern software development practices like version control, continuous integration, and testing in network operations. So basically, as you can, as you probably heard, we can use CI/CD pipeline in networking. We can use version control systems in networking, and we can, use these beneficial platforms and tools to test and handle our infrastructure better. So if we can collaborate with other network engineers, it's even better because they might add something, they might fix our mistakes, and it's extremely easy to do with model-driven programmability. With SNMP, you cannot basically just share your SNMP MIB configurations or whatever else easily with other network engineers. But with netconf, you, again, share just one young data model, and everyone collaborates on top of this model and decides what can be done to improve process and take it to the next level. And for that, you already have Git, you already have DevOps processes. Using software development, we can apply to networking, and model-driven programmability focuses on one single young model, and that facilitates everything because all we have to work on is just one model. So for today, I think it's enough. It was a common overview of model-driven programmability, why we need it, what it consists of. And this video was very, very high level. I couldn't go to details, but in next videos, I'm going to talk about every single component of MDP, like netconf, restconf, gRPC, the data formats, XML, JSON. We'll talk about Yang model in details. We'll have examples. So make sure to subscribe, make sure to follow. Thank you for watching. I will hope to see you in the next video. If you have any questions, please don't hesitate to ask under comment section. And don't forget to follow our page on Instagram. It's called SDMBit. And you can also contact us for network automation services. If you want to deploy any kind of net DevOps infrastructure, just make sure to ask us on Instagram page. Looking forward to hearing from you. Thank you for watching.